So this is question 9. We are given a cubic function of f of x equals to ax cubed plus bx squared plus cx plus d, and we have the point of our x-intercept and our y-intercepts here, and we are told that q and r are turning points of f. So this is the graph below here that we're given, and we are asked to find, so in 9.1 we are asked to find the value of a, b, c, and d. So we are having our f of x being equals to ax cubed plus bx squared plus cx plus d, right? And we are given points. P is 0 and 6, q is 1 and 0, r and s is 3 and 0. So for us to find the equation of this cubic function, we need to use this expression here, or this equation, a into x minus x1 x minus x2 squared. So why am I saying x minus x2 squared? It's because if you look at the graph, the graph has an intercept here at x equals to 1, right? That intercept is also the turning point. Hence, you have to say x minus x2 squared. You have to square that. That square means that it has a turning point and an x-intercept at that point. So we're going to substitute our x-intercept, which is 1 and 0 and 3 and 0, into the equation. So we have f of x equals to a into x. So we're going to start first with the minus 3 because it's the first intercept that doesn't attach itself with a turning point. So then the other intercept of 1 is also a turning point, so we need to write it here. So it's going to be minus 1 squared. So now that we have this, we're going to use a point which is our y-intercept to substitute it. Y-intercept when x equals to 0. So that point is 0 and 6. Why are we substituting this point? We want to find the value of a. So we're going to substitute it. Where there's y, we put 6. Where there's x, we put 0. So it's going to be 6 equals to a into 0 minus 3. And then 0 minus 1 squared. So it's going to be 6 equals to a into minus 3 and minus 1 squared. So we're going to have 6 is equals to minus 3a. Divide by minus 3, divide by minus 3. Our a value is going to be equals to minus 2. Right? So we're going to substitute that a value here to find our equation. So our a is minus 2, right? So it's going to be minus 2 into x minus 3, x minus 1 squared. So we have minus 2 into x minus 3. We're going to expand this, x minus 1, x minus 1 equals to minus 2 into x minus 3. And then we find the product of this. So it's going to be x squared minus x plus 1 equals to minus 2 into x minus 3, x squared minus 2x plus 1. Then we're going to find the product of these two here. So it's going to be equals to minus 2 into x cubed, this multiplied by that, and then the x multiplied by this minus 2, so it's going to be minus 2x squared, and the x multiplied by 1 is going to be plus x, and then this minus 3 times this x squared is going to be minus 3x squared, and then this minus 3 times this minus 2x is going to be plus 6x, minus 3 times 1 is going to be minus 3, right? So it's equals to minus 2 into, so you're going to collect like terms, so it's going to be x cubed, and you collect these two like terms, going to be minus 6x squared, and then these two like terms is going to be plus 7x and then minus 3, right? So the 2 minus 2 is going to multiply everything that is inside, so it's going to be minus 2x cubed plus 12x squared minus 14x plus 6. So this is going to be our equation of f, right? F of x, which is equals to minus 2x cubed plus 12x squared minus 14x plus 6. So our a value is equals to minus 2, our b value is equals to 12, our c value is equals to minus 14, our d value is equals to 6. In 9.2, we are asked to determine the x coordinate of the point of inflection of the equation of f. So we now know that our f of x is equals to minus 2x cubed plus 10x squared minus 14x plus 6. So we are asked to find the x coordinate of the point of inflection. So we have to find the first derivative of this. So it's minus 6x squared plus 20x minus 14. So we find the second derivative, which is equals to minus 12x plus 20, right? Then we equate the second derivative to 0. So it's going to be minus 12x plus 20 equals to 0. And then we're going to transpose minus 12x equals to minus 20. Divide by minus 12, divide by minus 12. Our x is equals to 5 over 3. So this is the x value of the point of inflection. 9.3, for which values of x is the function increasing? So how we solve this is we need to identify the point where the graph is increasing, which, if you look at this graph, the point where it's increasing is between this turning point and that turning point. So this point, this portion of the graph, it's increasing, right? So we need to identify the values of x when this graph is increasing. So we're having our f. So f of x, our f of x is equals to minus 2x cubed plus 10x squared minus 14x plus 6, right? So we need to find the turning points because the graph is increasing between those two turning points when x is equals to 1 and the other turning point that is unknown. So we need to identify that turning point that is unknown. So we first find the first derivative, which is minus 6x squared plus 20x minus 14. Then we equate the derivative to 0. So if minus 6x squared plus 20x minus 14 equals to 0, then we divide by minus 2 all sides, and then we're going to have 3x squared minus 10x plus 7 equals to 0. And then we're going to find the factors of this problem here. So it's going to be 3x and x, then 1 and a 7, negative and a negative, to give us the middle term. So it's going to be 3x minus 7 is equals to 0, or x minus 1 is equals to 0. So we transpose the minus 7 to the other side. We have 3x equals to 7, or x is equals to 1. So this was the first point of the turning point, which was already known. So we divide by 3 both sides here, so it's x equals to 7 over 3. So this is the other point of the turning point. So now because our graph increases between these two turning points, so we're gonna say x must lie between the 1 and 7 over 3. So this is the point where our graph is increasing. So now we're going to do 9.3.2. Says that k will we must find the values of k when f of x equals to k has exactly 3 real roots, right? So how do we find this? We go back to our graph, and we want to identify the values of k when the values of y, the roots of y are 3, right? So this is the first point where we have our roots of y, right, which is y is equal to 6, and this is the second point where we have the roots of y, which is y is equal to 0, and this is another third point where we have the roots of y, which is y is equals to we don't know, but we know that the x value of the turning point at this point is 7 over 3, right? So let's first find this y value at this turning point, and then we will identify the values of k. So we're having our f of x being equals to minus 2x cubed plus 10x squared minus 14x plus 6. So we know that the x value of the turning point at the other root is equals to 7 over 3, right? So we're going to substitute it in this equation here, which would be minus 2 into 7 over 3 cubed plus 10 into 7 over 3 squared minus 14 into 7 over 3 plus 6. So we're going to get 64 over 27. So this is the second y value, the turning point. So now when we go back to this portion here, I explained that we want the values of k such that the y values have 3 roots. So as I said here, the first root of y is equals to 6, second root of y is equals to 0. Now we found the third root of y is equals to 64 over 27. So what are the values of k when we have 3 roots from this point up to the last point? So we need to identify the value of x at the first point, which is equals to 0, and at the last point x is equals to 7 over 3. So you can simply say that k must lie between 64 over 27 and 0.